Okay, so yeah, hello everyone. So this tutorial is meant for giving an introduction on how Rasa works and essentially doing some basic functionality with Rasa chatbots, understanding how this functionality works, and uh, learning what we have already seen in the slides, like as a presentation exam, like in the presentation as well. So, yeah, essentially, one directory must have been shared with you, one GitHub repository. There are some commands which you can use to create an environment, Conda environment, and install Rasa. So, I hope you can follow that to create your environment. So, for in my case, I'll just activate my Conda. Yep, so my Conda has been activated, and I'll activate my environment now. Yep. So yeah, so we have installed Rasa. So the first thing that is there for our Rasa environment is to do a Rasa init. To Rasa init essentially is a simple command to uh, create a really base repository for the Rasa chatbot. So that is what we're going to do now. Rasa. Yep. So essentially, we want a project to be in a current directory. We don't want to train an initial model at the moment. And yeah, as you can see here, we have some sample. We have a sample repository with some sample files. So the main things that you can see here are this data folder. So essentially, how Rasa works is that in Rasa, the dialogue management is happens in a sort of different way. So instead of like your general chatbots that you know about, right? Like they usually work on rule-based architecture, and they're enforcing them, and they enforce these rules so that you're able to converse. You think that you're conversing with a chatbot, but instead, what Rasa does is it uses ML to learn conversational patterns. So what conversational patterns refer to, you will be able to understand in a second. But essentially, it uses some sample examples that you have of talking. So essentially, for greeting someone, you generally use like hello, good morning, how are you, hi, hello, hi with an exclamation mark, or hello. Like all of these are different examples of conversational patterns. And apart from learning conversational patterns, you should also know the context of a specific situation, right? So, in some context, so different um, how do I say it? Yeah, different sentences could mean differently in different contexts, right? So, essentially, uh, there can be multiple examples of it. I can't think one right off my head, but maybe something like, let's say you want to learn about something, or essentially you are telling about something. So uh, those two mean different things, but like in general, how do you say this? Okay, leave that example, but uh, what I mean by saying that is essentially your conversation after learning the conversational patterns, you should also be able to know the specific situation and the history of context that has happened before. So let's say if you're searching for a hospital, for example, so was there some place where the person told before? So let's say the person sent a message I need an ambulance at this place. So you already know the location. So your chatbot shouldn't be like, okay, where do you want the ambulance, right? You should be able to know that in this specific situation, the location should be directly extracted and stored. So in general file, generally NLU.md file is where we'll talk about entities and intents, and this is where we find the conversational patterns. So in our case, essentially what NLU.md holds is a lot of intents. So essentially we can see that there's an intent greet here, and what a greeting intent means is some examples are specified here, like hey, hello, hi, good morning, good evening, hey there. So all of these are greeting intents. Similarly, we have a goodbye intent, affirmation intent, denial intent, and so on. So, but in our case, since we are talking about conversational AI for teaching purposes, what we'll have is a different sort of NLU.md. So we'll have a greet summary. So what we'll try to create in this tutorial is we'll try to create a bot that summarizes some sort of topic that you ask about. So essentially what we want is an intent of greet. We also want an intent of summary asking. So when someone asks for a summary, we should be able to detect that intent. So we have a lot of examples for that. And then we have some intents for goodbye, for taking feedback, and for a positive and negative, like essentially if it's a positive response or if it's a negative response, and so on. So we should be able to detect these kind of intent. So let's copy this data sample example and use it in a totally new NLU.md file. Okay, yeah. So this is saved. Apart from this, we'll talk about what this regex is to topic means. So essentially, what the structure here is that some examples are here for the intent, but you can also define entities as well. So essentially, there's some example like what is atom. So what we are telling you here is that this atom here is an intent, which sorry is an entity, and that entity's name is topic. And we've given multiple examples of like atom thermodynamics, processes, division, cellular, animation, DNA. So it is able to learn from all of these examples. And another thing that we're telling is that this entity, which is our topic, we have specified a regular expression for that, that it can only be alphabetical. There can't be any numeric characters inside it. So that is what this regex comes in. So, apart from the examples, we also need to tell our model on how it should train. So, that happens in our config.yaml file. So, in our config.yaml, we tell the model about which uh, model to use and what are the. We'll talk about policies in a second. So, let's just copy the config.yaml file first. So yeah, we are telling it that we are using the Spacey NLP model. So Spacey NLP is a pre-trained model which contains embeddings for a lot of words. So that we don't have to create our own embeddings in this case. And what we are using is that essentially first it will tokenize our sentence. Tokenization means that we break our uh, chatbot's message into small words in that sentence, and these words becomes tokens. Next, we have the Spacey featureizer. Spacey featureizer essentially converts these words into vectors which come from the NLP's pre-trained model. Then we have the regex featureizer. Regex featureizer is used to check whether our entities that we specified are the following some sort of regex pattern. Like we saw in NLU.md that there's a regex pattern for topic which is just the alphabetical. So apart from the regex featureizer, this is a general module that every pipeline uses. It is a CRF entity extractor, and essentially it is used to extract the entities from these feature vectors to, and like from our text, essentially, it is able to extract this entities. And finally, there's the scalar intent classifier, which is the model that we are using. So here we specify which model are we using to train this thing. So let's save both of these and let's do a training of just the NLU module. So Rasa train NLU is the command for that. Yeah. So we can see in our data stats that we found intent, summary, create, goodbye, feedback, positive, and all of these intents we were able to found. We found these many entity examples, and we found one entity which was topic. Now what it is doing is it is going through each of these tasks in our pipeline. So it is training the spacey NLP component, loading the spacey NLP component, then the tokenizer, featureizer, regex featureizer, entity extractor, synonym mapper, and then the intent classifier. And the main part is to train the scalar intent classifier. So this is where the parallel job kicks in, and we start to actually do some epochs to train this. So we should be starting to see that in a second. Yep. And it has successfully saved our model into our models folder. This is where we have the model. So now we can actually test this uh, NLU classification, if we were to say it. So, so this is in general really helpful to see if like your uh, data set is imbalanced. So in our case, it is really imbalanced because we have only specified messages for summary. We have specified a lot of messages for summary and not that many for others. So possibly we won't be able to classify, like we will be able to classify the messages, obviously, but there will be some issues in confidence values. So let's see that. So let's say I typed a message hello. So what it will do is it will tell what all confidence values it has on each of these intents. So the top one here tells the intent that it classifies it to, like the maximum confidence it has. So it has a confidence of 0.58, 58% that it is a great intent, and the rest of it are 0.03, 0.03, 0.03, 0.02, something like that. And so it doesn't have a lot of confidence on the rest of those values, but it is able to tell that it is with 58%. So the 58% actually should have been something like 90 or 95, but because the data set is so imbalanced, it is not able to have a lot of confidence on this hello as well. So let's do give a summary of oxygen. Yep. So if we were to see, so we're telling that it is an intent of summary with a 99% confidence, and the entity here is oxygen. So we're able to see that there's like a very huge difference here. So 99% because and 58% in this breed, and yeah, so this is because of the imbalance too. But yeah, like this is just for example, so we can see that. And yeah, we can type yes, it will classify it as an intent that we are giving some positive remark, and so on. So essentially we can say that our model is working fine. So essentially it is able to detect the patterns in our uh, it is able to detect conversational patterns and able to classify entities as well. So, apart from detecting conversational patterns, the other thing that that we talked about was detecting the situation, the specific situation that the bot is in, and the history of like all the patterns that it has. So for this, what happens is we use a stories.md file. So what a stories.md file generally tells is that uh, a story is essentially telling you what are the different pathways, like different types of conversations that can happen between a chatbot and a user. So, let's say in our case, there can be a path where like a user, like essentially a user creates a bot, and the bot then creates back. Then a user asks for a summary for a topic, and he gets back the topic's definition. And now, in general, after this, it's important to have two more paths, because like in our case, how we have programmed our tell definition is that uh, we'll talk about how all of these individual components work, but just assume for a minute here that we are able to return the definition. So essentially, the user asks for a summary of a particular topic, and we are able to give him the summary of that topic. Now, what we do is, in the definition, we add one extra line telling, would you like to know more about this topic? So, in every definition, we are adding this line. So, because of that line, essentially our path now split. So, when we are going from create then summary, so now what happens is either the user can say yes or a user can say no to like knowing more about the resource. So essentially we get two more paths. So that is what, like, you can think about it like there's this greet section of the conversation. So a user can greet multiple times, and that greet component of the path keeps replicating. Then there's the getting the definition part. So once you ask for a definition, you have to specify a yes or a no. So in this case, this would be wrong actually. So essentially, in our case, essentially when you get a definition, you have to, the next sequence of things should be a response of a positive response or a negative response from a user. So that is what the summary part two and summary part three depict. And yeah, that like that that essentially becomes one component. We can actually add this as well. Essentially, what this means is that it can also happen that the user does not give any response. Like essentially, it does not give a positive response or it does not give a negative response. So it just ends. He just ends the chatbot at 10 definition. So we can add that path on here as well. So essentially, our summary has three pathways that it can take, and that summary three paths becomes one section. So we have the greet section right now, and we have the summary section right now in the path. Next, the next section that can come is a feedback section. So essentially, maybe the user wants to give a feedback, and he tells the bot that I want to give a feedback, and the bot says, "Okay, give feedback." Then the bot takes the feedback and utters thank you or something for giving feedback, something like that. So that again becomes one more section, and finally there's the goodbye section, right? So each of these become different sections, and in those different sections there can be multiple different types of paths that uh, a conversation between a bot and a user can take. So we try to mimic all of those paths. Obviously, we won't be able to cover all of them. So we try to mimic as many as we can, and we use it in terms of training. So essentially, in our case, let's copy the stories.md file. And as I told before, like these policies that are here, that are written here, are actually used to map these stories.md to the context that is going on in our chatbot. So essentially, memoization policy is one policy where we actually check, like, essentially, let's say I greeted, so it is able to connect that we are in the greet story, and in the greet story we can see that there is no next step. So essentially it ends right there after the utter greet. But then there's the action tell definition. So let's say a user asks for a summary of something, but then what the this memoization policy will see that it matches with one of them directly, but there are two more options possible. So essentially, memoization policy in general, it is either 100% matching or 0% matching. So, whereas Keres policy it takes a more probabilistic thing to that, where it tries to map probabilistically where we are lying. So when we are asking for definition, so essentially we have three paths, right, that one can take, and the one which is most closest is just the one where the definition ends. So that will have the highest probability, and then the other two will have kind of equal probabilities. So, but then if the user does give some positive or negative feedback, then they go for the our probability turns to zero, and the other probability also turns to zero, and we get 100% on one of those policies. Yep. So that is one thing. So we specified the paths in the stories.md file, and one important thing is that I want to talk about now. Essentially, after we have talked about stories and all, we can discuss about our domain.yaml. So, what domain.yaml represents is an entire universe of a chatbot. So, this actually represents everything that a chatbot has. So, what are the all the different intents that it has? What are the different entities that it has? We'll talk about slots in a second. What are the different responses that a bot can give? So, in general, a bot can give two types of responses. It can either be an utterance, which is essentially a string, just a string, or some custom responses where you are doing some pre-processing on the behind in some Python file and then sending back the response to the user. So yeah, these are two type of actions, and we define each of these utterances in our templates where utter greet is sending hi, utter goodbye is sending bye, and all of these utterances are defined here. Yep. So so one special thing that is there in my domain.yaml file is slots. So you can think of slots as a short-term memory sort of a thing. So essentially, when a bot is conversing with you, so maybe you told your location earlier somewhere in the chat, but now that location is lost, right? Because you only have that entity when you had that text, but now you don't have that text. The text has been different. So slots are generally are like a short-term memory where you can store these entities for later use. So in our case, essentially, we are storing the topic and we are specifying that this entity topic is of type text. So by default, if you specify an entity's name in a slot, it is automatically able to detect that it is an entity and it should store it and it directly maps to store it. So we've talked about how to declare utterances. We talked about short-term memory of bot. So let's talk about how do we define these custom actions of our bot. So we'll copy this domain.yaml. So to declare any custom actions, we have an actions.py file in our Rasa folder, in like Rasa init, we get an actions.py file. So by default, you'll see that Rasa provides a simple template for it. So this template includes like essentially you declaring a class which inherits from the class action from Rasa SDK. And in that, you generally need two definite functions. One's name is like one function's name is name, which tells like the name of the custom action. So this name should be consistent with what you have specified in domain.yaml. So action tell definition and stories.md like action tell definition. So it should be consistent with that name because this is how it uses to connect with the connect with this like connect this class uh, with that action. And the another one is the run function. And in the run function is where we specify what exactly are we doing. So what exactly should the like the what are the backend processes that should run, and then we should utter the message. Like essentially, it contains three parameters: dispatcher, uh, which is the parameter that we use to send messages to the user. tracker, which is the short-term memory that we have, and domain, which is the universe of the chatbot, and we can use it to get anything in our. You can use it to get anything in our domain, like in the universe of the chatbot, which we talked about earlier. So in our case, we won't be needing this. So let's copy these two actions that I have defined, and we'll talk about these two actions in a second. Yeah. So essentially, in my case, I have declared two actions. One is action tell definition, and one is action give resource. So action tell definition, what it does is essentially it gets the topic name from my short-term memory, and it uses. Right now, I have hard coded it, but in our case, we do some GPT-2 modeling to get the definition and check the similarity of the topic name with how much it is related to science or how much it is related to our pathway and things like that, and then we dispatch different types of messages. But in our case, I've just hard coded it. So if I'm sending the topic name is chromosome, I give a chromosome definition, or if it's genome, I give a genome definition. Otherwise, I'm just saying that I don't know the definition of this topic, and then I'm uttering that message out to the user. And similarly for give action give resource also, we are not doing much. We are specifying the name, we are getting the topic name, and we are just send like essentially we are just uttering the message wikipedia.org slash plus word. That's it. We're doing something like that. So now we have two custom actions that we have defined as well. So what we can do is we can now train our entire model. So with all the classes and everything, we'll specify a Rasa train to train our entire model, so that it is able to detect the all the stories and mapping all the policies with the stories. So now it is running all the epochs. You can see that accuracy is pretty good. So this accuracy is based off of our validation score. So essentially, it is taking samples from our NLU.md and putting it in the specified stories, and then similarly, it's taking samples again from NLU.md and testing against those samples only. Now we can do a Rasa shell command to test this model. Let's make this one. Oh, wait. Before this, I forgot. So what you have to do is this actions thing. So essentially, to interact with your Rasa actions, you have to run an action server separately. So for that, what you do is you specify Rasa run actions command, and what this will do is it will run your actions file in another server. Okay, sorry, and the wrong module. So we have to go inside the testing graphs directory. Yeah. And now we run the Rasa run actions. So what this will do is it will start our action server, and we will be able to contact this action endpoint server in a Rasa shell to interact with. So you can see it registered two functions, tell definition and give resource, in our action endpoint server. So in general, you can specify this endpoint in your action endpoint.yaml file. So you tell that your actions files endpoint is localhost 250 In general, it directly hosts on that server only. So yeah, I think this is okay. So now we can go back to our lesson, and we can run a Rasa shell. So it will start a Rasa server on 5005 because like essentially in a Rasa shell also we are creating a local server of 5005. So it has to do some HTTP calls to connect with the actions file as well. So it also is another server. So let's check if our greet is working. So we specify hello and our bot returns hi. Okay, that's great. So give me a summary of chromosome. Yep. So it was able to detect that we were asking for it was a summary intent, and what do you know? We are able to get a chromosome is a linear segment of DNA that contains the instructions for the construction of gene. So would you like to know more about the topic? Let's do a yes and see if we are able to get the link. And we are. So wikipedia.org/chromosome. We are able to get a link to get more info about it. So this is one path. We can also specify goodbye, and it will. Yeah. So because I made an n-gram error, it did not detect the correct intent, and it just used the tracker's short-term memory. So that happens sometimes. So this is what happens when your data is sparse, right? Like you have a lot of data in the uh, uh, actions thingy. So in the summary thingy, so by default, its confidence score goes high, right? So it classifies any random thing that you send to that, and your tracker already has a topic from your conversation, so it just uses that to get the definition. So yeah, shortcomings in every application, right? Like goodbye is there, and like essentially we let's do another part where we're spending high. So let's ask for a summary of genome. Let's write it like this. What is genome? So it returns me a definition of genome. So let's time I don't want to know about this topic. So it tells me bye. So this is all for this Rasa tutorial. If you have any more doubts, I'll be happy to like you can just for like there's like a lot of tutorials that are out there which will tell you, but if you have any specific doubt with your applications you can ask me on my email id saksham.agarwal at iitb.ac.in, or you can just contact me uh, in campus maybe, or yeah, like the or you can just contact Chaitali ma'am from WSL Labs and she'll be able to solve your queries as well. Thank you.